All right. In the figure below, a pump forces water at a constant flow rate through a pipe whose cross-sectional area A gradually decreases at an exit point. A has decreased to 1/3 its value at the beginning of the pipe. If y equals 60 centimeters and the flow speed of the water just after it leaves the pump, point 1 in figure, is 1 meter per second, what's the gauge pressure at point 1? So I'm guessing the pump is point 1 and the exit is point 2. So we could solve for velocity. So velocity is actually pretty easy because it tells us about the cross-sectional area changing and the proportion of which it changes. They told us velocity 1. And they told us at what proportion it changes. So this equation's still good. You're not wrong. We could use the velocities. If the velocity starts at 1, wait, when is it at 1? Just after it leaves the pump is 1 meter per second. So at the very beginning, it's 1 meter per second. But then it shrinks down to by what? How much area? 1/3 of the area. So what do you think about the speed? 3? So V2 is going to be 3 meters per second. It's 1/3 the area. If this goes down, then this has to correspond by going up. Okay? Goes down by to 1/3. Then this has to go up 3 times. All right. So if we have the proportion of the speed, that's a good starting information. It tells us a lot of information and it has a picture. What does this picture have in it? What's the difference between point 1 and point 2?
1.6 meters.
You have
0.6 meters.
you have a height change.
Yeah.
We just discovered we have a speed change. Yeah, a velocity change. And also there's a pressure pump, right? And so what we're looking at here is the pressure based on work that the pump is doing, plus the pressure based on the speed, plus the pressure based on how high it is at moment 1 versus moment 2. So the hardest part is, this is not supposed to be an equals. The hardest part is sometimes just identifying what kind of question is it really asking. And this is pressure 2, velocity 2, height 2. And so this is a Bernoulli's principle. Okay. Well, we have, what kind of liquid is this? Water. So we're looking at the pressure just as it's leaving the pump. That's P1. That's what we're looking for. Plus 1/2 rho of water. Velocity. What's the velocity at the beginning? 1. Plus rho GH, right? 1,000 times 9.8. And just like potential energy, what's the height here? It's the lowest point. We can make this our relative zero height. Oh, that makes this problem a little bit easier. Equals pressure 2. What's, oh yeah. It's allowed to be, it's allowed to shoot out into the world. So that's atmospheric pressure, 101, 300, plus, right, pascals, because we're doing everything in meters and kilograms. What's this one? 1/2, 1,000, and times what? 3 squared plus rho GH, 1,000 times 9.8. What's our height this time? 0.6. I'm almost out of space. All right. Well, that's not too bad. Pressure 1 plus 500 plus 0. Oh, that's going to save us space. Equals 300 plus 9,000 cut in half is 4,500 plus, I don't expect you to do this in your head. I've been here enough to have multiples of 9.8 memorized. Is that it? Can we find the pressure at the beginning? I feel like we have just solid numbers. I had this number memorized. I think it's 1111 880. Yeah. I just keep on writing ones until I get to the 8.
111,180 pascals.
Wait, but here's the problem. That's the pressure at 1. That's the absolute true pressure at 1. What's the gauge pressure? What is gauge pressure even? Minus the atmosphere. Remember when we added this atmosphere in? You could secretly have just not added it in. You could have secretly not had to worry about the pressure outside here. Kind of like in Bernoulli's problems where we didn't worry about it. If we pretended that this didn't exist, we would have never added it in. We would have never added it into here. Now, because we did, I'm just going to subtract it out. If I subtract it out, isn't it just the 4,500 plus this minus 500? So it's just 4,000 plus that is 9,880. I think that's easier. What did you do? I said this doesn't exist, which means this doesn't exist. So 4,000 plus the 5,880. Yeah, pascals. And this is, what do we call this one? Gauge pressure, right? Pressure GA, I think is a good abbreviation. I don't know. That's an 8, by the way, not a 9. All right.